Hello everyone, my name is Tank Darshit. Currently I am pursuing Masters in Construction Engineering and Management from CEPT University. My student code is PCM24079. I'll be presenting about our studio construction project execution, monitoring and control, which focuses on execution phase of the construction project, which includes commencement, planning, construction and maintenance. The execution phase is very important as it manages the resources like time, money, manpower, machineries, and materials to meet the client requirement. The studio aims to analyze construction processes using the knowledge areas like cost management, quality management, safety, planning, and lean construction. Here in this video, I'll be discussing about my work on the real life project, which includes pour planning and materials management. This research center is anticipated as a hub for biotechnology innovation. The goal of this project was to address critical challenges in agriculture, healthcare, and environment through innovation, collaboration, and sustainable development. Let's take a look at the key specifications of this project. The project is located in Gift City, having a total site area of 9,735 meters square with a built-up area of 18,976 meters square. The total estimated cost of this project is 108.42 Cr. It consists of one basement, ground floor and 6 upper floors. The total duration of this project is 21 months starting from September 2024 and ending in July 2026. The scope covers core and shell, interior, MAP, finishing works and maintenance. The mode of this contract is divided into two parts, that is item rate for basement and lump sum for the superstructure. The major construction activities observed as on 22nd April 2025 were reinforcement for pour 2 slab for the ground floor level, shuttering for first floor at pour 1 and pour 3. The pie chart here shows the cost breakdown for the scope included, in which we can see that the majority of the cost is occupied by the civil works and the least by miscellaneous works post construction. Now let's see how quantities, cost, coefficients and productivities were calculated for this project through pour planning. It is a very critical part of any construction project, and for this project it was done with much attention to ensure the systematic execution. The basement was divided into 6 pours and typical floors were divided into 3 pours. The scope for this assessment includes the ground floor and 6 upper floors. As I already mentioned about the 3 pours at ground floor, each of them are further subdivided into 5 zones to maintain uniform and orderly workflow for making of vertical members. These zones allowed us to execute tasks like starter works, column casting, beam and slab making and casting, and staircase for organized manner. To streamline the construction process, we have used Microsoft Project for scheduling. The net floor area of the ground floor is approximately 2,774 meters square, while the upper floor ranged between 2,031 and 2,425 meters square. The area for pour 3 reduces at 5th and 6th floor. For formwork, this project has EcoSpeedy frame system for the vertical members like columns and shear walls, and conventional formwork system used for the horizontal members such as beam and slab. This is the set code repetition prepared for this project. Consistency in construction method was the key focus area, and this was achieved using the set code repetition for elements like beam, slab and columns across the floors. Each element was grouped into sets, set A, B and C for each pour, while columns or vertical members were further divided into 5 zones from zone 1 to 5. The blue row in the set code repetition for the beam and slab is a suggested extra set for beam bottom to make construction method faster. The number written in bracket represents the number of repetition for the element. This systematic approach not only ensures uniformity across the floors but also reduces the errors and rework. By clearly defining the sequence of tasks and assigning unique codes, the project team can be able to maintain high level of efficiency and accuracy across the construction process. Next is coefficient, productivity and direct cost. This tells us about the details of material usage, productivity and cost. The formwork for vertical member costs around 312 rupees per meter square, while the same for horizontal member it costs around 514 rupees per meter square. The direct cost for the reinforcement comes out to be 74.64 lakhs for pour 1, and similarly the costs were derived for the rest of the parts. The steel to concrete coefficients were another aspect of this analysis. For the vertical members, the coefficient range from 101.37 to 48.46 kg per cubic meter, while for the beams and slabs, it ranged around 159.64 to 71.27 kg per cubic meter. This consistent coefficients helped us to optimize material usage and minimize the wastage. In terms of productivity, the team achieved an average of 214 kg of steel per man day and 3.2 to 4 meter square of formwork completed per man day. These numbers reflect the efficiency of the workforce and effectiveness of planning. Next, we have calculated the peak requirement for reinforcement and concrete monthly based on the schedule prepared on Microsoft project. The peak demand for the reinforcement was about 120.8 metric tons, while concrete requirement peaked at 131 cubic meters in certain months. The cost comparison revealed some valuable insights. For instance, using an in-house batching plant proved to be more cost efficient than relying on ready-mix concrete. Similarly, tower cranes emerged to be more economical and efficient option compared to manual handling methods. Couplers, though initially more expensive, were preferred over lapping due to their ability to reduce overall reinforcement cost. Now let's take a look on material management. Efficient material management was another highlight of this project. The procurement process was streamlined to ensure timely delivery and high quality materials. Steel had a lead time for just 6 days from indenting to site arrival, while the concrete had an exceptionally shorter lead time for just 1 day due to its location benefits of in-house batching plant. The procurement flow involved multiple steps from arising purchase requisition to vendor selection and order placement. The tools like ERP softwares were utilized to track material availability and ensure the seamless coordination between site and head office. This structured approach minimized the delay and contributed to project's overall efficiency. The material receipt process places a strong importance on quality control. The flowcharts presented over here for the both process are little bit self-explanatory. Upon delivery, the materials underwent through inspection by QA/QC department. Only after meeting all the quality standards, they are approved by planning department and documented in ERP software through GRN. This process not only ensures the use of high quality materials but also maintains the accurate inventory records. Vendor evaluations were conducted based on time, cost, and quality, ensuring that only reliable suppliers were engaged for this project. Now, here the cost and material analysis was performed using ABC analysis, which tells us about such 10 to 20% of the A class material having cost around 70 to 80% of total cost, 25 to 30% of B class materials having 30% of total cost, 60 to 70% of C class bulk material having 10 to 12% of the total cost. ABC analysis is a cost multiplied by usage approach. Similarly, HML analysis was done, which is just cost per unit approach. Reinforcement accounted for the highest material cost at 98% of the cumulative cost, despite of having a moderate unit rate. Couplers, due to their high efficiency, were categorized as high cost material, while concrete and binding wire were in medium and low categories respectively. The analysis helped us to know the high value material and allocate the resources strategically, and ensuring both cost effectiveness and quality standards were met. Also, the economic order quantity for the steel was calculated based on the peak demand, as I already mentioned in pour planning. So this analysis tells us the optimum quantity of 42.66 tons which can be purchased at a total cost of 1.34 lakhs including a total ordering and carrying cost. Next is economic order quantity with purchase price variation. This analysis tells us how the economic order quantity model was applied to optimize steel procurement. The optimum order quantity was calculated to be 42.66 metric tons, balancing ordering and carrying cost to achieve a minimum total cost of 8.77 crores. This approach highlighted the importance of bulk purchasing material for cost efficiency while maintaining sufficient inventory levels to avoid project delays. So, in a nutshell, this project showcased the importance of accurate planning and systematic execution in construction. From poor planning to materials management, every aspect was designed to optimize efficiency, reduce cost, and maintain quality. Tools like EOQ and ABC analysis proved to be valuable for cost control and inventory management. Sustainable practices such as in-house batching plant and tower cranes further enhance the project's eco-friendliness and cost efficiency. Overall, this project provided a means of learning opportunity and demonstrated how innovative results can lead to seamless execution and successful project delivery. Thank you.